Hi guys, FreakCdev here. So today, in this video, we will be creating our own blockchain in just 60 lines of JavaScript. So this video was originally from my tutorial article on dev.to. So I want to give huge appreciation to individuals who have supported my article on dev.to. It really helped me to keep the series on the run. So I will put a link to my article on dev.to in the description so you can check it out. So now let's get started. Okay, so I'm just gonna create a file called jchain.js because I love the name. Okay, so before we do any coding, we need to understand what a blockchain is. Technically, a blockchain at its bare minimum is just a list containing objects that have some basic information on it, like timestamp, transaction, hash, and its data must be immutable and unhackable. Modern platforms like Ethereum, Cardano, Polkadot have way more complex stuff than that, but we're staying simple in this video. And note that the blockchain needs a decentralized P2P server to run. Basically, it consists of machine called nodes, and each node has a blockchain. But I will talk about it in the upcoming videos of the series. So now let's start coding. So as I've said, the blockchain consists of multiple blocks represented as objects. So we should have a block class to easily create blocks. So it should have information like timestamp and data. So we're just gonna create a class called block, and we have our constructor, which we're gonna pass in timestamp and data. Timestamp gonna be a string originally, and data gonna be an array. So we're gonna have our timestamp, okay, so here's a block, right? But one features from blockchain is that the blocks must be immutable. So we can ensure the immutability by having a hash property. So basically, this hash property will contains the hash of timestamp, data, previous block hash, and we are going to gain that hash by using a hashing function. So here I'm just gonna call get hash, and we're gonna create a get hash method. So it's gonna return the hash data, and actually we need to turn it into a string first. Okay, plus timestamp. We also gonna have a property called pref hash, which holds the hash of the previous block. We're just gonna leave it to be empty by now because we don't know what is the previous block, right? And to implement a SHA-256 algorithm, I'm just gonna import the package, the crypto package from nodejs, and then I'm just gonna create the SHA-256 hash function, just like this. SHA-256, we take in a message and returns the hash. Okay, so we're gonna create hash SHA-256 update message, and we're gonna get it as hex. So if you haven't known about hash and cryptography in general, I suggest finding them out on Wikipedia, because this is a pretty popular knowledge in blockchain, right? Okay, so we have our block, we have our timestamp, data, hash, pref hash, and we have our getHash method, which returns the hash of the block. All right. So then we will create our blockchain. So with our blockchain, as I've described before, the blockchain is basically just a list with blocks. So I'm just gonna create a chain property, which is just an array, and we'd also like a genesis block. So what is a genesis block? It's just basically the first block in the chain, right? This block will keep the chain up and running as we do stuff in this article, right? But just understand it as the first block in the chain, right? So we're just gonna have the timestamp. I'm just gonna use date.now because it's cool. And I'm just gonna leave the data to be empty. So we have our chain. We would like to also have a way to add our block in. We're just gonna pass in block as argument. So because we are passing a block, we must need to ensure that the block's pref hash is the current latest block of the chain, so which is technically this dot get last block dot hash, and we're gonna create this get last block method, which returns the latest block in the chain. So we're just gonna do it like this. Okay, pretty simple, isn't it? So we also need to recalculate the block hash, right? So we're just gonna call get hash again to recalculate our hash, right? So we're just gonna push the block to the chain, just like that. Okay, so we have a function to push the block into the chain. So I'm just gonna create a new chain here. I'm gonna call this J chain. It's gonna be new blockchain, and I'm just gonna add a new block to it. We have our timestamp and then our data. I would like to note that data usually contains stuff like transactions if you are creating a cryptocurrency, but for now I'm just gonna do anything I want, right? Okay, so I'm just gonna open up our trusty terminal and run the chain. Oh wait, I'm sorry, it's supposed to be toString. Okay. Oh, I forgot to console log out the chain. We need to look at the chain, right? Alright, so we have our genesis block here, and we also have our newly created block, and you can see that pref hash contains the hash of its previous block, right? So it's pretty cool right now. So one thing that you want to do is to check if the chain is valid or not. So in the P2P server, there are no third-party system to check if a block is valid or not. No, you need to manually check if a node's blockchain is valid or not. So I'm just gonna create a function to check if a chain is valid, because normally you want to replace your chain with the new chain, right? So with the new chain that they sent, right? So I'm just gonna create a is valid method. I'm sorry, it's gonna be this, right? So I'm just gonna set it its default value to this, because if you want to check if your chain is valid or not, yeah, you can do that if you want. Okay, so I'm just gonna iterate over the chain. Okay, so we're just gonna blockchain dot chain dot length. Okay, and we should have a current block and our previous block. So the current block, oh, I'm sorry, it's gonna be 1. So we have a current block and a previous block. Okay, so a chain is valid when the current block hash is unchanged, right? And it's also and also the current block's pref hash should be equals to the previous block hash. So I'm just gonna create a really simple if statement. Get hash and or sorry, I almost used the AND operator. So block prep hash not equal to the prep block dot hash. Then we're gonna return false. And if every block is valid, then we're just gonna simply return true in the end. One nice thing about the Genesis block is that you can do stuff like this, right? If your chain has a length of 2, you can have the current block as the latest block, which is a second block, and the previous block as a Genesis block. So that's a very nice thing that the Genesis block could bring, right? Okay, so now let's check if our isValid function worked. So normally, let's see if our chain is valid. Okay, I'm just gonna, so it's valid, right? I'm just gonna change the block, right? Because one thing that I forgot to mention about the hash function is that when you change a really little tiny detail of anything in the block, the hash will comes out way different. So it ensures that like you can notice that the block is changed, the block is mutated. So yeah, so this is gonna ensure the blockchain immutability. Okay, so we're just gonna change okay, so I'm just gonna change the current block to, let's say, data. Okay, data gonna be 1, and let's see if it's valid or not. Of course it's not, right? Because data is now changed. It shouldn't have been changed. It's because it should be immutable. You can see that hash and pref hash is pretty cool here. It can ensure that a block, the blockchain can't be changed, because if you change a block, hash, the next block previous hash doesn't match anymore, right? So it will be an invalid change. However, you can technically just assign the hash. You just need to recalculate the hash and then recalculate the previous hash of the next block, and do that continuously, and you would still get a valid chain. So to fix this, we have a consensus mechanism called proof of work. So proof of work requires scanning for an amount of zeros. That amount is often called difficulty, or something related to difficulty. It's not usually difficulty, but to say simple, in this article, I'm just gonna refer the amount to difficulty. So imagine you have a hash like this. I'm just gonna type some nonsense out here. Alright, and we have a difficulty as 1 or something. So it requires you to so this is a process called mining. So we gonna add a new value here called nonce, which gonna start at 0, and we're gonna add it to the hash function. So what does nonce do? Well, basically, proof of work requires you to scan for an amount of starting zeros, right? So to do this, we're just gonna increase nonce continuously until we get the amount of zeros wanted. So like if you have the difficulty of 1, we're just gonna increase nonce until SHA-256 returns a hash which starts with 0. So we are done. So we can have a difficulty of 5, so it requires scanning for 5 starting zeros. What it would do is that if the difficulty gets increasingly big and bigger, if you are an attacker and you want to change a block in the past, you need to mine from that block to the current block, which seems impossible. That's the first case. The second case is that even if you somehow mine through that, and you currently have the perfect chain, you will still never catch up with the others in the future. Your chain will never be as long as the others in the future, unless you have 51% computation power in the whole network. So that's just the two reason I'm gonna say today. But the main reason of the existence of a consensus mechanism is technically not that at all. It's more like a way to stop, to prevent normal users from being attackers, rather than actually trying to stop attackers. So technically, if you mine a block, normally you would get rewards. So it would keep you from not being fallen to the dark side, right? But in this I guess this episode, you can just understand that it prevents the proof of work consensus mechanism prevent changes to the blockchain. But in reality, if you have a peer-to-peer network, a fraud chain will completely be dismissed, and proof of work actually just acts as a way to give you rewards, so that you wouldn't be on the dark side, right? Because if you have the 51% amount of nodes in the P2P server, you can effectively manipulate the network. So okay, let's implement the system. So we're just gonna simply add a mine method which takes in the difficulty as an argument. Okay, so we're just gonna simply increase the nonce value until we get the hash we needed, right? So we're just gonna do a simple while loops and a starts with method. So we're just gonna generate a string. So technically, this will create an empty array with the length of difficulty +1, and when you join that, you're gonna get the string consists of zeros with the length of difficulty +1 -1, so it's just the length of difficulty, right? So if it doesn't match, we're just gonna continue increasing the nonce value, and we're just gonna update the hash as well. So let's run the chain, right? Oh no, I forgot. You need to effectively create a props called difficulty, and it's originally gonna start at 1, and you're just gonna call block.mine this difficulty. Okay, perfect. Alright, so now every time we want to add a block, we need to mine it first. So we're just gonna paste some block out, hello world or hello world. Right, okay, perfect. Okay boys, so we have our chain here. Okay, so we can see the nonce increase to get the blocks mined to get the hash, right? But the thing is that keeping a static difficulty, or just make the difficulty always at 1, is a really stupid idea. Like you would need to change the difficulty, right? Because I would tell you 2 scenarios that can happen. The first scenario is that you might set the difficulty too high, so and nobody used your chain, and your chain gonna stuck there forever. And the second scenario is that the computer industry evolves, and it's just too easy at that time for them to mine, so your chain will be completely ruined. So we need to change our difficulty, right? Alright, so I'm just gonna implement a really dumb system for this, but first we need to have a look at block time. So what is block time? Block time is effectively the estimated time for a block to be mined. I'm not gonna care about that. I'm just gonna set it to 30,000 right here. Okay, so I want to adjust the difficulty every time the block is mined. So I'm just gonna do something really simple here. Right, okay, so I'm back. So So technically, after we mine this difficulty, right, we just gonna need to adjust the difficulty to be so date.now will get the current time minus the time that took the timestamp of the block when it's pushed. So we need to put it right here. Okay, so we have difficulty. So technically our formula gonna be we're gonna get the difficulty to decrease if if the current timestamp minus the block timestamp, which is technically the time took to mine the block. If it's greater than the block time, we just gonna decrement it by 1, and if it's smaller than block time, we're just gonna increase it by 1. So that could create fairness, right? Okay. Right. Okay. So yeah. So let's try our new proof of work system. Right. So now you would see that it gets increasingly harder to mine the block, and I would like to console log out everything to see the difficulty. So the difficulty has raised to 4, and you can see that it took way longer to mine a single block right now. Okay, so I'm gonna talk about the Bitcoin difficulty formula. So we're just gonna create a new file here, and so it's technically just alt difficulty multiplied by 2016, which is just 2016 blocks, multiplied by 10 minutes, which is technically 10, 16. And we also gonna multiply it by 1000 because we want millisecond, right? So we're gonna have our mining time. Actually, I'm just gonna reduce this to 10 minutes because we are writing pseudo formula stuff right now. Okay, so we have mining time for the block. Bitcoin uses this formula to calculate the next difficulty, and it's worth noticing that it doesn't straightly compare this like this. Nah, it would be really stupid indeed. It would normally do something like round log 16 difficulty. So if you want, you can change this to this. So if you do it like this, you can use the Bitcoin difficulty adjustment formula. Right. Okay, so we have just created a proof of work blockchain. This video was inspired by Simply Explain. Please check them out. I have left a link in the description. So in the next episode, I'm gonna talk about how you can create transactions and how you can create a P2P server and release your own cryptocurrency. So yeah, so that's all for today. For now, peace.